This video is the solution to paper 2 of ExamCraft Mock Paper 2021, Leaving Cert Higher Level Maths. If you're looking for paper 1, check out our separate video. So question 1 here is asking us to find the area of a triangle given 3 vertices. And what you're doing here is you're using your formula from your log tables for the area of a triangle when you're given the corners or the vertices of a triangle, and your formula in your log tables is area is equal to half times x1 times y2 minus x2 times y1. So that's the formula from our log tables. We need to amend or translate our coordinates. So our 3 coordinates are -1, 4, and I need to basically move or translate one of these corners, these vertices, to 0, 0. So 3, 2 and 5, 3. Doesn't matter which one you pick to move to 0, 0. I'm just going to pick the very first one here. So to make -1 become a 0, I have to add on 1, and to make 4 become 0, I take 4. And I need to do the same to the other 2 coordinates because I'm basically picking up the triangle and moving it. So my new coordinates are 0, 0, 4 minus 2 and 6 minus 1. I eliminate the 0, 0, and I now use my other 2 coordinates and I call them x1, y1, x2, y2. I then come back over here to the left and I sub them into my formula for my log tables. So the area of this triangle is equal to half multiplied by x1, which is 4, times y2, which is -1. Use your brackets, even though I know they don't show it in the log tables, but because we've minuses here, just to be safe. So it's half multiplied by -4, minus by minus gives me a +12. So it is half of 12, take 4, which is 8. The brackets are basically your modulus brackets, which means you turn your solution to a positive. It's already a positive, so half of 8 is 4 units squared. Okay, so that's question 1a. Scrolling down now to question 1b, it's asking us to do what? Find the coordinates of W, the point of intersection of the line L and the line that passes through these other 2 points. So it basically looks something like this. You have your line L, and then there's another line that's cutting through it. And this new point that we have is created by 2 points S and T. So what we have to basically go off and do is find the equation of this line here. What is the equation of this line? And then we'll use our simultaneous equations to find the point of intersection. So I'm basically going to come over to the right here and do a little bit of rough work. I'm going to take my 2 coordinates, S and T, which are 7, -6, and -3 and 2. And I'm just going to find the equation of the line between those 2 points. So first of all, I need to just label your points, x1, y1, x2, y2. I need to find the equation of the line. And in order to find the equation of the line, I need a point, which I have, and a slope. So I need to find a slope first of all. So I'm just going to, again, come over here and do a little bit of rough work first. y2 minus y1 over x2 minus x1, our formula for slope from the log tables. And filling that in, I get 2 minus -6 over x2, which is -3 minus 7. That's giving me 8 over -10, which will simplify to an equivalent fraction of 4 over 5 negative. So -4 over 5. Doesn't matter where you put your minus to when you're writing down your slope. I'm now going to come back up and I'm going to fill them in to my equation of the line. So this was just a little bit of rough work here. So my equation of the line is now going to be y minus y1, which is -6, equals my m, which is my slope, -4 over 5, times x minus 7. I multiply across by 5, so I get 5y. 2 minuses give me a plus, and the 5 multiplied by the 6 gives me 30. So quick way of knowing this is basically you're multiplying everything on the left by that 5. And on the right hand side, it leaves me with -4 times x minus 7. And that gives me -4x then, isn't it? Yeah. And -4 by -7 gives me a plus 28. And I'm going to move everything to the left hand side. So I'm going to have my 4x was a minus, so I'm adding 4x to both sides, plus my 5y plus my 30, and I'm taking 28 or moving it over So that's giving me a final equation of the line between S and T as 4x plus 5y plus 2 is equal to 0. Not finished, I now need to find this point of intersection that they want me to find between the line L and the line created by ST. So I'm now taking my equation of L, which is 2x minus 3y equal to minus 1. So I'm just moving the constant to the other side of the equals. And then I'm taking my new equation of the line, which is 4x plus 5y. And again, I'm letting it equal to my constant. So when it moves over, it becomes a minus 2. I'm solving that. So I'm going to multiply the top line by a negative 2. So that's giving me a new equation of minus 4x. Minus by minus gives me a plus 6y, and a minus by minus gives me a plus, and 2 by 1 is 2. And my second equation is 4x plus 5y equals negative 2. And that will simplify as my minus 4x and my plus 4x will cancel. 5 and 6 is 11y, and 2 take away 2 is 0. So y in this case is 0 divided by 11, which is 0. And our final step, because our point of intersection must have an x and a y. So sorry, my screen is just jumping here. Now find y. And I'm going to sub, you can do your simultaneous equation again, but I'm just going to take the quick route here and I'm going to sub my value of x, or my value for y, into one of the equations. Doesn't matter which one you sub it into. So I'm subbing in 0 for y. So that's giving me 2x minus 0 is equal to minus 1. So that gives me 2x is equal to minus 1. X is equal to divide across by 2. So x is equal to minus and a half. So therefore, my point of intersection is equal to minus a half, comma 0. That is the point of intersection. And that is question 1b part 1. So we're going to scroll down now and look at the second part of part B. So it's asking us to find the point W divides the line segment ST in the ratio A is to B. Determine the value of A and B. So find the values of A and B. So first of all, I'm going to draw my line segment here created between S and T. And I know the coordinates of S and T are 7, minus 6. And minus 3, 2. It's then telling us that this new point that we've just found, W, is somewhere on that line. So it's dividing it in the ratio A is to B. And we need to find that ratio basically. And we found the point W to be a half, minus a half, 0. So I'm going to use my formula from page 18 in my log tables about dividing a line segment. And it's written in our log tables as B times x1 plus A times x2 divided by B plus A. And my y coordinate then is b times y1 plus a times y2, all divided by b plus a. And that then is equal to my dividing point, or in other words, my w. And I'm going to label my s x1, y1, my t x2, y2. And my half 0 is going to be my dividing point, my answer, basically. So filling that in, I don't know my a and b, so keep them as b and a. So it is b multiplied by x1, which is 7, plus a times x2, which is minus 3, all over b plus a, comma b times y1, which is minus 6, plus a times y2, which is 2, all over b plus a, and that is equal to my dividing point, which is minus a half, 0. And just tidying that up, 7 by b is 7b, minus 3 by a is minus 3a, and that's all over b plus a, comma minus 6b plus 2a when I multiply them in, and all over b plus a, and that's equal to minus a half, 0. Okay, so I now know that this part is equal to minus a half, and I know then that the second part is equal to 0. So I'm just going to pair them up. Now, it doesn't matter which ones you pair up, you'll get the same answers, but I'm going to match up the y coordinates because I know one of them is already 0, so it's easier to deal with that 0 than the minus a half. So I'm going to take, so therefore, I know that minus 6b plus 2a all over b plus a is equal to 0. I'm going to put that 0 over 1, and I'm going to cross multiply or get a common denominator, but cross multiplying is the simple way and quick way of doing it. When I cross multiply, I get 1 multiplied by minus 6b plus 2a, which is minus 6b plus 2a, equal to 0 multiplied by b plus a, which is 0. I'm going to add 6b to both sides, or move over that minus 6b, so it becomes a positive 6b. And you can see here now that if I divide both sides by 2, I get 1a is equal to 3b. Or in other words, 1a is to 3b. And therefore, my ratio, in other words, is a is to b, which is 1 is to 3. And that's our answer. My ratio of a is to b is 1 is to 3. Now, it doesn't matter, again, as I said, if you took the left-hand side of the x part to that question, you would still get your ratio as to be 1 is to 3. Okay, so that's part 2 done. Scrolling down now to part C. So part C, the line L intersects a line with a slope m forming the acute angle of 45 degrees. Find the two possible values of m. So from our log tables here, we're taking the angle between two lines formula. So basically what's happening here is we have two lines are intersecting each other, and they're giving us the size of the angle to be 45 degrees, and they've given us the equation of one of the lines. We need to find the slope, two possible values of the slope for that second line. So from our log tables, I'm taking down our tan theta is equal to plus or minus m1, our first slope, minus our second slope, all divided by 1 plus m1 times m2. So that's coming from my log tables. Before I start, I need to come out here to maybe the right hand side and manipulate the line L. So I'm taking the line L, which is 2x minus 3y plus 1 is equal to 0. And I need to write that in terms of y. I need to get the slope of it. So minus 3y is equal to minus 2x minus 1. So that means that y is equal to minus 2x over 3, or minus 3, I'm dividing across by minus 3, and minus 1 divided by minus 3. So therefore, my first slope is equal to positive 2 over 3. So the two minuses become a plus when I divide them, and that is the slope of L. So I'm going to take that and sub it into my formula here. So my tan theta, my theta is the size of the angle, and it's telling me that I have an acute angle of 45 degrees. So I'm subbing in my 45 degrees for theta. My plus or minus, my first slope, well, I've just found one of them there to be 2 over 3. So let's sub that one in. And I'm subtracting my second slope. So I have m1 as 2 over 3. And I'm now dividing that by 1 plus my first slope, which is 2 over 3, times my m2, and I'm just going to call it m now. If I go to my calculator and type in tan 45, I get 1 is equal to plus or minus 2 over 3 minus m, all divided by 1 plus 2 over 3m. That's when I multiply the 2/3 by m. Next thing I'm going to do now is I'm going to put this 1 over 1, I'm going to make it fraction is equal to fraction, and I'm going to cross multiply. I'm going to solve for m here now by cross multiplying. Now what you have to be careful with is you have to worry about this plus and minus value here, that there are two values for my slope. So first of all, I'm going to have 1 over 1 is equal to plus, and then I'm going to multiply that plus into 2 over 3 minus m. So I'm going to just put that in a bracket because I need to multiply in that plus all over 1 plus 2 over 3m. And my second value is going to be 1 over 1 is equal to minus, and then multiplied into 2 over 3 minus m, all over 1 plus 2 over 3m. So basically what I'm doing there is I'm doing out my plus or minus for both slopes. Now I'm going to cross multiply, and what that will give me is 1 multiplied by the denominator will give me 1 plus 2 over 3m multiplied by 1, which just stays as 1 plus 2 over 3m, is equal to 1 multiplied by, now you can see here when I multiply in that plus sign, my signs won't change. So 1 multiplied by 2 over 3 becomes 2 over 3, and 1 multiplied by minus m will give me minus m. And on my second one, when I cross multiply on this one, I will now have to first of all multiply in this minus into my bracket. So I'm actually just going to rewrite my fraction there with the 1 multiplied in, or the minus 1 multiplied in. So that gives me 1 over 1 is equal to, and when I multiply in that minus, I get minus 2 over 3. Minus by minus m gives me a plus m all over 1 plus 2 over 3m. Now I'm going to cross multiply. And that is going to give me 1 multiplied by the denominator is giving me 1 plus 2 over 3m is equal to 1 multiplied by minus 2 over 3 and 1 multiplied by positive m. Okay, so let's finish both of these out. So I'm just coming back to the one on the left here now. I'm going to rearrange it. I'm going to put the m's on the left. So that gives me 2 over 3m. I'm adding m to both sides, and then I'm subtracting 1 from both sides. And 2 over 3m plus m is giving me 1 2/3 m, which is basically 5 over 3m. So it's like 1 in front of this m. So 2 over 3 plus 1 is 5 over 3. And that's equal to 2 over 3 minus 1 is giving me minus 1/3. And to get m on its own, I now need to go minus 1 over 3 divided by 5 over 3. So I'm dividing both sides basically by 5 over 3. And that's giving me a value of m as minus 1 over 5. I'm now going to come over to the right hand side and finish off solving for m here. So I have 1 plus 2 over 3m and equals to minus 2 over 3 plus m. So again, I just need to rearrange it. I'm going to bring the m's to the right hand side. So I just need to move over this 2 over 3m and bring over this negative 2 over 3. So that will become 1 plus 2 over 3 is equal to m plus minus 2 over 3m. And 1 plus 2 over 3 is giving me 5 over 3 is equal to m minus 2 over 3. Well, that's 1 minus 2 over 3, which is 1/3 m. So m then is going to equal 5 over 3 divided by, let me just scroll down a little bit more, 1 over 3. And when I divide 5 over 3 by 1 over 3, I'm getting 5. And the question wanted us to find two values for m. Well, there they are. There's my first one, minus 1/5. And my second one is positive 5. And with those questions, you will always notice that one of them is the reciprocal of the other. So they're the perpendicular slopes, really, I should say. Okay, that is question 1 done. Let's have a look at question 2. So let's scroll on down here to question 2. So the first part here, so 3 circles, okay, we have that. They're touching, you have a radius of r. So let's just write in you have or basically all along here. Just filling in everything I know. The line K cuts circle 2 at the point X and Y, and it's tangential to C3 at the point Z. Okay, show that D is equal to 3 over 5 or. Okay, so basically what we're looking at here is, if I kind of look at my picture, you can see here that I have this triangle here. So I'm looking at this smaller triangle, and then what I'm going to do is I'm then going to look at this larger triangle coming out to my radius here. So I'm going to basically compare those two triangles, and I'm going to basically look at similar triangles with those, because we know that they're both going to have 3 of the same angles. So they're basically creating, if you remember our rules of tangents and so on, this angle here is going to be 90 degrees because it's a tangent to the circle, and this angle in here is also 90 degrees because it has our chord xy, and when you draw a radius to a chord, it will always create that 90 degrees. And that's 2 things that are equal. And then we also have this angle which is common to both triangles. So that's why we can use our similar triangles here. So let's just draw them out. So what do we have? Let me just get rid of some of this highlighter here so you can see which triangle I'm drawing first. So I'm drawing out this small triangle, and it's going to look something like, again, it's only a sketch just to help yourself. Now, what's the length of the base? The length of the base is going 3 radii, isn't it? 1, 2, 3. So I have 3 or. I have a 90 degree here, as we said, because it's coming up to the tangent, or sorry, coming up to the chord. And then this side is known as D. And on my larger triangle, so let's just rub all this out, I'm looking now at this triangle, and if I sketch it, again, it's very rough. I have my 90 degree where it touches the tangent. How many radii do I have now for this base? I have 1, 2, 3, and I'm adding on another one, a fourth and a fifth. So I have 5 or as my hypotenuse across from the 90 degrees, and I have or as the side of the triangle. So if I match up my similar sides, okay, because similar triangles are proportional, so I have, using similar triangles, we'll say, I'm going to have, I could say D over or. So I'm matching the D and the or, and then I'm matching the 3 or equals the 5 or. Okay, I need to get it as D is equal to 3 over 5 or. So what I'm going to do there is I'm going to cross multiply. And when I cross multiply, so I'm just going to go this way, I'm stuck for a bit of space here. I'm going to get D multiplied by 5 or, which is 5 D or. And when I multiply or by 3 or, I get 3 or squared. And then to get D on its own, I need to divide both sides by 5 or. So that gives me 3 or squared divided by 5 or. And you can see now that I can cancel an or into one of these ors at the top. So that means, so therefore, my final solution here is going to be D is equal to 3 over 5 or. And again, let's just write it in the form they want. They want us to separate out that or, so 3 over 5 times or. And that is finding the value of D. If we come down now to part 2 to that question, it wants us to hence or otherwise show that the value of the length xy is equal to 8 over 5 or. Okay, so let's just scroll up here to our picture and just see what we're looking at here. So they're getting us to write the line xy. So let's just highlight off the line xy and see where we are. So I have xy, which is this length here. And what I'm going to do here is I'm going to basically create a triangle coming from the center of this circle C2 out to x and out to y. So I'm creating that triangle here. So let me just create these two lines in red first of all. So I'm coming from the center out to x. Now the length of that line is a radius because it's coming from the center to the edge of the circle. And same here out to y, it's also a radius. Now we know that this angle in here is 90 degrees because it's a radius, it's a line coming from the center of the circle out to a chord. This blue line now is my chord. So I'm basically looking at an isosceles triangle there. And what I'm basically going to do here is I'm just going to take half of this triangle. I'm going to take this one here. I'm going to look at this triangle in yellow and I'm going to just label this point here in the middle of x and y. I'm going to label it P for point. So I'm basically just looking at that triangle there. And all I'm going to do basically is find the length of PY, because we know by the definition of a chord that a chord will be cut into two. It'll bisect. So let's just draw out a circle here so you can see what I mean by that. So if I have a chord and if I draw my radius coming from my center into this chord, and that means it creates 90 degrees on either side of that line coming from the center to the chord. But what that line does, it bisects my chord. So it cuts it into two equal parts. So that's basically what we're looking at here. We're going to get the length from P to Y and then multiplied by 2. So let's come down and I'm going to sketch out that triangle PY and the center. So how does it look? So my triangle looks something like this. So P, Y, and then I have that center point of the triangle. I'm going to put in my 90 degree. What do we know now? We know that this length is D. As per my picture, I know that this length is or because it's coming from the center out to the edge of the circle, and I need to find PY. Now I know also that D from part 1 up above can also be written as 3 over 5 or. So this question I'm just going to look at in terms of or. And in order to get the length from p to y, I'm just going to use my Pythagoras theorem. So my Pythagoras theorem is c squared equals a squared plus b squared. Just make sure that the c is always the hypotenuse. So the hypotenuse is across from the 90. So this is my c, and my other two sides are my a and my b. It doesn't matter which is a and which one is b, as long as you get the c, the hypotenuse, correct. So my c is going to be r squared. My a is going to be 3 over 5 r, all to be squared, plus my b, which is py squared. And all I'm going to do then is I'm just going to manipulate this. So this is going to give me r squared is equal to 3 over 5 squared is giving me 9 over 25. R squared is r squared plus py squared. I'm just going to move the r's to one side. So I'm basically moving this over or minusing it from both sides. So that's giving me r squared minus 9 over 25 r squared is equal to py all to be squared. Okay, if I now subtract 9 over 25 r from 1 r, I'll get 16 over 25 r squared. So go to your calculator basically and go 1 minus 9 over 25. And that is equal to py all to be squared. I'm just going to bring it up here now because I'm running out of a bit of space. So that's 16 over 25 r squared is equal to py all to be squared. Now think to yourself, how do we get rid of that py squared? How do we get rid of the square? Well, we're going to find the square root of both sides. So that is giving me 16 over 25 r squared is equal to py. And the square root of 16 over 25 will give me 4 over 5. And the square root of r squared, one of the r's will cancel with the square root. So that's giving me r. So just again, go to your calculator and type in the square root of 16 over 25. And that is equal to py. Now I need not just find py, I actually need to get the distance from x to y. So you can scroll back up and have a look at your diagram there again. But basically, so therefore xy is equal to twice this because I need to get the full distance from x to y. So when I multiply that, I get 4 over 5 multiplied by 2 is 8 over 5 r. And that is my value for xy. And you can see that's what they wanted us to find here in the top of the question. So that there is a part 2 to question 2a. Okay, so let's have a look at the next part of that question, part B. So let's scroll down and see what they want us to do. So part B, find the equation of the circle that has a center on the line L and passes through these 2 points. So there's different ways of doing this question. What I'm going to do here is I'm going to form 2 equations of the line and find the point of intersection of those 2 lines in order to find the center of the circle. So what I mean by that is I'll do a sketch here so we can see the approach I'm going to take to this question. But like I said, there are different ways of doing it. So what we have here is the line L and it sits on the center of this circle. And what I also have now is 2 points, 7, 6, and 5, minus 4. And what's happening here is what I'm going to do is I'm going to find the equation of the line that goes through these 2 blue points. And I'm then going to get the perpendicular slope and form the equation that goes through the center of this line that goes through the center of the circle. So that's what I'm going to form. I'm going to form this equation here of the line, let's call it n. And it's very similar to the previous part of the question. Basically, there's a few steps involved. As I said, you first of all find the equation of this blue line here. And in order to do that, I need to get the slope and the midpoint. And then I form the equation of the perpendicular line that goes through the center. So there's a bit of work. First thing I'm going to do is I'm going to find the slope of the line between the 2 points, 7, 6, and 5, minus 4. So I'm finding the slope between these 2 points. So y2 minus y1 over x2 minus x1. So that's coming from my log tables formula. And labeling my 2 points x1, y1, x2, y2. And filling that in, I get m as slope is equal to And what do we get? y2, which is minus 4, minus y1, which is 6, divided by x2, which is 5, minus x1, which is 7. So m is equal to minus 10 over minus 2. Minus divided by minus is positive 2 into 10 is 5. So that's the slope of the blue line. I now need the equation of the line that's perpendicular to that. So I need the slope of this yellow highlighted line now, n. So therefore, the perpendicular slope, so that's my symbol for perpendicular, is equal to the reciprocal. Flip it and change the sign. Okay, so that's my minus 1/5. Next thing I'm going to do is I now need to find a point on that yellow line n. Now I can't use the center because I don't know what the center is. So what I'm going to do here is I'm going to get this purple point that I've just marked, and that'll be the midpoint of 5, minus 4, and 7, and 6. So I'm now going to come up here and I'm going to find my midpoint. So my midpoint formula, once again from my log tables, is adding my x2 values and x1, dividing by 2, adding my y values and dividing by 2. So I'm getting the middle of the two of them basically, and x1 is 7, x2 is 5, y1 is 6, y2 is minus 4. Dividing it by 2 gets me 12 over 2, comma 2 over 2. And 12 divided by 2 is 6. 2 divided by 2 is 1. So that's my midpoint there. So what I'm now going to do is I'm going to form the equation of the line. So I'm now using these to form the equation of the line. And that equation of the line is now going to be called n on my one. So again, it's this yellow highlighted line now that I'm finding. And I'm now using my slope, which is m, which is minus 1/5. Just be careful here that the point you use now must be your midpoint, which is 6, 1. So just make sure that you're using the 6, 1 there as your point on this line, and that's going to be my x1 and y1. Your equation of the line now from your log tables is y minus y1 is equal to m multiplied by x minus x1. And subbing everything in, I'm now going to get y minus my y1, which is 1, equals my m, which is minus 1/5, times x minus x1, which is 6. First of all, I'm going to get rid of the fraction of 1/5. So I'm going to multiply across by 5 to eliminate my denominator there. So again, you're just multiplying the left hand side by 5. So that gives me 5y minus 5 is equal to minus 1 times x minus 6. I'm going to multiply in this minus 1. So I get 5y minus 5 is equal to minus 1x. Minus by minus gives me a positive 6. And I'm just going to move everything to the left hand side. So I'm going to add 1x to both sides and subtract 6. And that is giving me positive 1x plus 5y minus 5 minus 6 is equal to 0. Because I want to eliminate everything on the right hand side. I want to get it equal to 0. So that means I have 1x plus 5y minus 11 is equal to 0. So I'm going to come up to my picture, and the equation now of this blue line here is now going to be x plus 5y minus 11 is equal to 0. Now what I'm going to do is I'm basically going to find, using simultaneous equations, the point of intersection between that line that I've just formed, the equation of that line, and the equation of the line L. So where those two lines now intersect is going to find me the center point to this circle. So I'm just going to put it there in blue. So I'm now finding that point there. So using simultaneous equations, again, apologies, now my screen, I'm kind of moving around here, but just to keep a bit of space on the screen. So using simultaneous equations between L and N, it doesn't matter which one comes first. I'm going to put the L, 2x minus 3y. I'm going to move over that positive 4. I'll do it in a second, actually. Let's just write it in as it is. And the one I've just found is x plus 5y minus 11 is equal to 0. And I'm just going to subtract 4 from this one and add 11 to this one. I like them just equals to the constant. So that means I now have two equations. 2x minus 3y is equal to minus 4. 1x, or just x, plus 5y is equal to positive 11. And what I'm going to do now is I'm going to multiply the second line by -2. I want to cancel out these x's. So multiply the second equation by -2. So the top one stays the same. 2x minus 3y equals -4. The bottom one will become -2x. Multiply 5 by -2 becomes -10y. And 11 by -2 is -22. And then 2x take away 2x is 0. So I can cancel them out. -3y minus 10y is -13y. And -4 minus 22 is -26. So therefore, y is equal to dividing both sides by -13. Minus divided by minus is plus. 13 into 26 is 2. So there's my y coordinate of my center. So I'm going to come up here and I'm just going to write in my center y coordinate as 2. I now need to find x. So now find x. Now you can do your simultaneous equation again, but I'm just going to take a quick route here and I'm going to sub in my value for y. So I'm going to trust myself that y is equal to 2. So you can take any one of the equations, it doesn't matter which one of the four you take. I'm taking the 2x minus 3y plus 4 is equal to 0. And I'm going to sub in my value for y. And I got 2 for y, so I'm just going to sub that in. And multiply in that -3, and I get 2x minus 6 plus 4 is equal to 0. Therefore, 2x is minus 2 is equal to 0. Add 2 to both sides. I get 2x is equal to 2. And when I divide across by 2, I get x is equal to 2 divided by 2. X is equal to 1. So, scrolling back up, where are we now? We've now found our center of the circle, which is 1, 2. So I'm just going to write that in. So this, therefore, center of circle is 1, 2. Okay, so we're nearly there. What next? Let's write down the equation of a circle from our log tables. The equation of a circle from our log tables is x minus h all to be squared plus y minus k all to be squared equals r squared, which is radius. Now the center is your h and k. So h and k I know, so let's fill them in. So I have x minus h, which is 1, all to be squared, plus y minus k, which is 2, all to be squared, is equal to radius squared. Now I don't actually know what my radius is, so I need to go off and find my radius now. So we're not quite there yet. So let's have a look at finding our radius. I'm just going to scroll back up to my picture and see how do we find the radius. So if I'm looking at my picture here, the radius is basically the distance from the center of the circle out to one of those 2 points, either 5 minus 4 or 7, 6. It doesn't matter which one you find the distance to. So what I'm going to do now is from my log tables, I'm going to use the distance formula. And my distance formula for my log tables is x2 minus x1 all to be squared plus y2 minus y1 all to be squared in a square root. So that's coming from my log tables. Now the distance I'm now subbing in as or, that's trying to find my radius. The 2 points that I'm going to use here is I'm going to have to use the center, and the center is 1, 2. And as I said, you can take either one of the other 2 points that are sitting on the edge of the circle, and I'm going to take 7, 6. Like I said, it doesn't matter. You can also take 5 minus 4. Labeling those 2 points, x1, y1, x2, y2. Filling them into my distance formula, I get x2, which is 7 minus x1, all to be squared, plus y2, which is 6 minus y1, all to be squared, all in a square root. That means then that r is equal to the square root of 7 take away 1, which is 6 squared. 6 take away 2 is 4 squared. 6 squared is 36. 4 squared is 16. So that means that r is equal to the square root of 52, which is the same as r is equal to, in third form, 2 root 13, which is the same thing. So I can finally come over and sub that in now for my radius. So therefore, the question asked us to find the equation of this circle. The equation of my circle is x minus 1 all to be squared plus y minus 2 all to be squared is equal to my radius, which is 2 root 13, or square root 52, all to be squared, which is x minus 1. You don't need to multiply out these brackets, so you won't gain any additional marks, but you do need to simplify the radius, and 2 root 13 squared is 52. And that's the equation of the circle. Now, just if you've done it another way, I'm just going to write down the answer. So bear with me here until my screen is jumping on me. This is also the same as, if you want to write it an alternative way, if you did this question a different way, just that you can check your solution, that is also the same as x squared plus y squared minus 2x. So this is just when I multiplied out the solution, minus 4y minus 47 is equal to 0. So it's up to you which form of the equation of the circle you want to write it in. Both are absolutely fine. Okay, so that's question 2 complete. Scrolling down to question 3. So question 3a part 1, the attendance at a local rugby match is dependent on the weather. The probability of a large crowd attending if it is raining is 0.35, and the probability of rain on a match day is given as 0.3. So if we read this sentence here again, which says the probability of a large crowd attending if it's raining is 0.35, that's basically the same as me as saying it's given. So I'm just going to write the word given here. So it's like the probability of a large crowd attending given that it is raining is 0.35. So I'm basically going to be looking at my conditional probability here for A part 1. And I'm just going to write down some other things that I know here. So the probability of rain and a large crowd is basically the same as the probability of rain intersecting with large crowd. So I'm just writing it mathematically. And I know then also that the probability of a large crowd, if it rains, is equal to the same as the probability of large crowd given rain. So that's basically the same thing. A large crowd, if it rains, is the same as a large crowd given that it's raining. And that's equal to my 0.335, I should say, like I marked up in the question. Something else that I know is that the probability of rain on a match day is equal to the probability of rain is equal to 0.3. So next thing I'm going to do now is going to write down my conditional probability rule, which is the probability of A given B has happened is equal to the probability of A intersecting with B all over the probability of B. Now this is going to change for my question as the probability of L, large crowd, given it's raining, is equal to the probability of large crowd intersecting with rain over the probability of rain. And I'm going to fill that in now. So what do we know? We know the probability of large crowd rain is 0.35 from up here. So I'm going to fill that in first of all. And that's giving me 0.35 is equal to the probability of large crowd intersecting with rain. Well, that's basically what we want. We want to find what's the probability of rain and a large crowd. So that's the unknown. So I'm trying to find the probability of large crowd intersecting with rain. And that is all over the probability of rain. Well, we have the probability of rain from the question. It's 0.3, isn't it? Sorry, I wrote down 0.35 here for the probability of rain. The probability of rain is 0.3. And then I'm going to solve for the probability of large intersecting with rain. So I'm just going to put this over 1. I'm going to solve my two fractions by cross multiplying. And when I multiply 0.35 by 0.3, I get 0.105. And that is equal to the probability of a large crowd intersecting with rain. Or in other words, rain and a large crowd. That's part A, part 1. Looking at part 2 here now, it's asking us to find the probability of a large crowd attending is 0.8 on a match day. Verify that the probability of a large crowd attending and rain occurring are not independent. So our rule for independent is given by the probability of A being multiplied by the probability of B is equal to the probability of A and B intersecting. So in our question, we're basically looking for the probability of a large crowd multiplied by the probability of rain equaling the probability of large and rain happening together. So if we fill in what we know from the question up above, we know the probability of a large crowd is 0.8, which comes from here actually, 0.8 on a match day. So that's where that 0.8 is going to come from. So we have 0.8 multiplied by the probability of rain, and we have that from the very top of the question where it says the probability of rain on a match day is 0.3, and we want that equal to 0.105, and that's what we found up above in part I. When I multiply 0.8 by 0.3, I get 0.24. And now I want to show that that is equal to 0.105, which it's not. So I conclude that 0.24 is not equal to 0.15. So therefore, since they are not equal, they are not independent. And that's what the question asks us to do. Show if they are not independent events. And that is part 2. So scrolling on down now to the next part, part B, part 1, we're getting into probability selecting from a bag here. So we have a bag containing 15 colours, 6 blues, 4 red, 3 yellow, 2 green. 4 discs are chosen at random from the bag. Find the probability that the 4 discs are blue. Now here, the discs we're going to have to assume are not being put into the bag. It doesn't say that they are being replaced, so I'm going to assume that they're not being replaced. So what does that mean? Basically means blue and blue and blue and blue. And in probability means to multiply. So and means multiply or means to add. The probability of picking out that first blue, so I have 6 blues in the bag, so that's going to be 6 out of 15 discs in total in the bag. And if I put aside a blue, that means that I only have 5 remaining in the bag, and I only have 14 discs in the bag. So I've put aside 2 blue discs, I have 4 remaining, and I only have 13 in total remaining in the bag. And my 4th disc means I only have 3 to pick from if I've assumed that the previous 3 are also blue, and that's out of 12. And when I multiply those 4 fractions together, I'm getting simplified as 1 over 91. So that's B part 1. B part 2 is asking us that the 4 colours are the same colour. So what colours have we got? We have, they could be blue, they could be red, they could be yellow, or they could be green. Now the question says that the 4 discs are the same colours. But if you think about it, I can't have 4 yellows. Can't happen because there are only 3 yellows in the pack. So I'm basically going to ignore the yellows. I'm also going to ignore the greens because there are only 2 greens in the bag. But this question wants us to show the probability of 4 discs of the same colour. So really what can happen here is I can only have blue, a blue, a blue, a blue, or I can have a red, a red, a red, a red. I can't have yellow or green. So I have blue, 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 blue from part B, part 1. So I'm going to take that answer now in a second. The word or, as we said in maths, means to add. And now I need to look at finding the probabilities of 4 reds. So there's 4 reds in the pack. So my first colour is going to be 4 out of 15. I remove one of the reds. That leaves me with 3 out of 14 remaining in the pack, and so on. So 2 out of 14, and then the final red, which is 1 out of 13. Sorry, I made a mistake there. It should be 15, 14, 13, and 12. When I multiply the 4 15ths, 3 14ths, 2 13ths, 1 12th, I get 1 over 1,365 plus my answer from B part 1, which is 1 over 91. When I add those 2 fractions together, I get 16 out of 1,365. So that is part 2 to that question. So let me just double check my answer there with that. Yeah, so 16 out of 1,365. Scrolling down now to the final part of this question. So it's asking us now to find the probability that the 4 discs are of different colors. So the 4 discs are different colors. So what I'm going to do here is I'm going to use my choose button on my calculator. So let's think of it like this. So I have 6 blues in the pack. So I have 6 blues and I want to choose 1 because I am picking out 4 different colors. I'm then going to go and my next one I want to have my reds. So I have 4 reds and I want to pick 1 red out of that group. I then come along to the yellows. I have 3 yellows in the pack and I want to pick 1 of them out at random. And then I'm going to go and, which means multiply. I have 2 greens, so I go 2 and I want to choose 1 of those. And what I'm going to do then is I'm going to divide that by, because again we're looking for probability, it must be a fraction. The total number of discs in the bag is 15 and I'm choosing 4 discs from the bag. So that's basically the fraction that I'm setting up. And think of it like this. 6 choose 1 is 6, 4 choose 1 is 4, 3 choose 1 is 3, 2 choose 1 is 2. So that's basically, you might look at it like this with the boxes around them. You're counting down the different ways of getting your reds, greens, yellows and blues. And I'm dividing that by 1,365. And when I multiply the top line, the numerator line, I get 144 over 1,365, which simplifies down to 48 over 455. And that is question 3. Next thing we're going to do is scroll down now and try question 4. So question 4 is moving on to statistics. The number of hours of sunshine and the maximum temperatures is given by this table here. First thing they want us to do is to plot the information onto the scatter graph, the scatter plot. So let's have a look at that. So I'll try and make enough room here that we can see the data and graph it. Sorry about that. Now my screen is just jumping to the next question. Here we are. Okay, so let's see. The first one, 11 hours and 13 temperatures. So I'm coming to 11 and up to 13. So it's bringing me about there. 11 and 13. What I'm going to do now is I'm just going to plot 1 or 2 and I'm going to pause it and complete, show you what the complete table will look like. So let's do one more together. So 17 hours of sunshine and it's going up to 21. So I come up to my 17, so you can draw a dotted line like this if you want, and come across from 21, which is here. So my coordinate is here. So let's just see what the table would look like when it's complete, or a scatter plot, I mean. So that's our scatter plot, and my last one there is 1417, which is bringing me to 1417, which is about there. Okay, so that's my scatter plot complete. No need to draw the line of best fit, it didn't ask for it. So we're now going to go down to part 2. And it's asking us to calculate the correlation coefficient or from this data. Give your answer to 3 decimal points. Now, I'm just going to write down the steps on the calculator. So the steps on your calculator, if you're using a Casio FX83 GT Plus, Google actually a separate video there on for the new Casio calculator. You'll see it there, a separate video that I've done out. So if you just check our channel of videos. So we go to mode. I'm using the older calculator here now, and then I'm going to press 2 followed by 2, and then I'm going to input my data. I'll talk us through these steps now in a second. Then I'm going to press the AC, then followed by the shift, 1, 5 and 3. So I'm going to talk you through these steps here now. So first thing you need to do is clear your calculator. So you should press shift 9, follow the online instructions. So clear the setup, yes equals AC. Important that you clear your calculator. Press the mode button, press 2 for stats, and then press 2 again for a plus bx. You want two variables basically. You should get a table with x and y appearing on it. Now you basically input your data, all of the x coordinates. So the x coordinates I'm going to use as the number of hours of sunshine. So I go 11 equals, 17 equals, 15 equals, 13 equals, 12 equals, 10 equals, 10 equals, 10 equals, 12 equals, 14 equals. I arrow over to the y coordinate and I scroll back up to the very start, number 1. And I put in the maximum temperatures. 13 equals, 21 equals, 20 equals, 19 equals, 15 equals, 16 equals, 12 equals, 14 equals, 14 equals, 17 equals. Now I want to save the data. I press AC. So on my screen, I'm basically finished these steps here. I now press the Shift button. I press 1, which says Stat above it, to retrieve the data. I press 5 on my calculator, REG it says, and now I'm looking for the letter R to stand for correlation coefficient, which is number 3 on my calculator. Press 3, press equals. Up should appear the number now, 0.865261, and the question wants it to 3 decimal points, so 0.865. So that's my correlation coefficient for part 2. Scrolling down now to part B, it's the expected value question. A game consists of rolling a coloured die with 3 red sides, 2 green sides and 1 blue. So it has our standard 6 sides at least. A roll of a red loses, a roll of a green pays 2 and a roll of a blue pays 5. So we have listing out our options first of all. So I can get a red, a red, a red. So there's 3 reds. I could get a green, and I could also get a blue. So there are the 6 options that can happen. Looking what happens with the red, what can we get when we get a red? So the probability of getting a red here is 3 out of 6. So there's 3 reds out of the 6 on the counter. And the probability of greens is 2 out of 6 on the die, and then a blue, which is 1 out of 6. So there are the probabilities of each one of them happening. In order to find the expected value, we now multiply these by the amount that you win or lose for rolling that number. Now, look at the green and the blue first of all. The green pays out €2. So I'm going to multiply that by €2. And the blue pays out a whopping €5. So I'm going to multiply that by 5. Now, if I roll a red, I lose. But it costs you €1.50 to play. So even though you roll a red, you still have to hand over €1.50. So I'm going to lose €1.50 there. So I'm putting it in a bracket with a minus to denote that I'm losing. When I multiply 3 over 6 by minus 1.5, I'm ending up with a loss of 75 cents. When I multiply 2 over 6 by €2, I'm ending up winning, on average, 0.6 reoccurring, or 66 cents. And when I multiply 1 over 6 by a fiver, I'm ending up earning 83 cents on average. When I add 83 cents, 66 cents, and minus 0.75, I'm ending up with 0.75 in gains. So that's telling me, the question then says, would you play this game? Explain your answer. I would say yes, because the expected value is above 0. I'm earning 75 cents in addition here. Now, let's look at it actually. It cost me $1.50 to play the game. So I'm on average earning 75 cents. So perhaps actually no. I'm only earning 75 cents and it's costing me $1.50 to play. No, actually we're good. Yes, the expected value is above 0, so I'm happy with that. So we're coming out on top here. Next question. I think that's fine, isn't it? So yes, the expected value is above 0 because we've included our €1.55 loss there in our expected value. So no, we're good with that. Next question is question 5. So we're getting into angles and circles here. What's question 5 asking us here? Find the size of the angle AOC. So let me just fill in AOC. First of all, I need to connect A to the center O. They didn't do that for me. And they want us to find the angle AOC. So I start at A, come over to O and down to C. So it's that angle in here between my two radii, basically, isn't it? And we should hopefully remember that the angle at the center of my two lines coming from the arcs is twice the angle at the edge of the circle. So basically what I'm doing here is the angle AOC is equal to 68 times 2, which is 136 degrees. So that's one of our theorems that states that the angle at the center of the circle is twice the angle at the edge of the circle. Next part is part 2, question 5, part 2. Hence, find the length of the minor arc AC. So the minor arc is this smaller one here from A to C. So they want me to find the length of that arc. What I'm going to do is I'm going to sketch out this sector of the circle, actually. And I'm going to fill in everything I know from that. So that circle, or sector, I mean, comes from the center out to A and down to C. And I have my arc that they want me to find the length of. I know that the angle at the center of the circle is now 136 degrees. And the distance from O to A and O to C is both radius, so 4 centimeters and 4 centimeters. I'm going to my log tables and I'm taking the formula for the length of an arc, which is angle over 360 times 2 pi r. So that's coming from my log tables, filling in my theta, which is my angle, which is 136 over 360 times 2 times pi times r, which is 4. And I'm using the pi button on my calculator. I'm not changing it to 3.14 or anything like that. It didn't ask me to. And when I multiply the fraction by 2, by 4, by pi, I get a length of an arc of 9.5 centimeters to 1 decimal point. Scrolling down now to B part 1. It wants me to express sine 3 theta plus sine theta as a product of sine and cosine. So what I'm using here is I'm now going to go to page 15 in my log tables. So we need our log tables now for this one. And I'm taking this now from the sum to products down the bottom of page 15. And it states this: 2 sine A plus B over 2 is multiplied by cos A plus B divided by 2. And that is equal to sine A plus B plus sine A minus B. So I'm using that rule from my log tables. And what I'm going to do here is, what I know is that I have already sine 3 theta. Let me just rub that out there. My numbers seem to have come down with me. I seem to be typing, so just let me clear that for a second. Plus sine theta. And what I'm going to do now is I'm going to fill this information into the left hand side. So that's going to be the same as 2 times sine A plus B. Now my A I'm going to assign as 3 theta and my B being theta. So that's going to give me 2 sine A plus B, which is 3 theta plus theta, all over 2 times cos A, which is 3 theta, plus B, which is theta, all over 2. And when I divide 3 theta plus theta, which gives me 4 theta, so let's just, before we divide it by 2, I have 2 times sine 4 theta over 2 times cos 4 theta. Sorry, that's a negative, I should say. Sorry, so it's 3 theta minus theta. And 3 theta minus theta is 2 theta. And when I divide that by 2, I'm getting stuck for space here. So let's go this way over here. So 4 theta divided by 2 is 2 theta. So it becomes 2 sine 2 theta times cos 2 theta divided by 2. So 2 theta divided by 2 is 1 theta, or just theta. And that is my answer. So express sine 3 theta plus sine theta as a product of sine and cos. And I forgot my cos here, which should read cos theta. And that's our answer. 2 sine 2 theta times cos theta. And apologies, it's kind of crammed in. They didn't leave us much space there. The next part, part 2. So part 2, hence or otherwise, find all of the solutions to this particular equation in the domain from 0 to 360. So what I'm going to do here is I'm going to take my equation, and we've rewritten it as, from part 1, 2 sine 2 theta times cos theta. And I'm letting that equal to 0. I'm just going to divide across by 2, so I get sine 2 theta cos theta is equal to 0 over 2, which is sine 2 theta times cos theta is equal to 0. And I now look for two solutions that multiply to give me 0. And I could either have sine 2 theta as 0 or cos theta as 0. Think about it like this. If I had the equation xy is equal to 0, I could have either x as 0 because 0 times y is 0, or I could have y as 0. X times 0 is also 0. So you have two possible solutions there. So what I'm going to do is I can have, so therefore, I can have sine 2 theta is equal to 0, and I have cos theta is equal to 0. And I'm just going to solve both of those, so trigonometric functions here. So from my calculator, I'm going to go 2 theta is equal to sine inverse of 0. So 2 theta is equal to 0 there. And if I divide across by 2, well, 0 divided by 2 is still 0. And when I do the cos here, I get angle, or theta, is equal to cos inverse of 0. And that gives me an angle of 90 degrees. Okay, next section we're going to look at, just bringing you now to my unit circle, and in particular the cast part of our unit circle. So check out our other video there if you need assistance with the unit circle and the cast. But basically what it's saying here is, so I have my 0 degrees, 90 degrees, 180 and 270. And if I focus here on the angle of 90 degrees for the cos part, so where is cos positive? So we're looking at here, this is my 90 degrees. And that's in all sections, so cos must be positive there. And if I come down, where else is it positive? Is in quarter 4, which is this angle in here. So that angle there is technically, my reference angle is 90 degrees, but it is also, and theta is also equal to 270 degrees. So if you type in your calculator cos 270 degrees, you will get 0 for that. And that's the cos function part done. Come over here now to the sine part. I'm now focusing in on this section here. I have theta is equal to 0 for sine. So basically you're looking at some of the remaining angles. So we've done the 90, we've done the 270. Well, actually, let's take them off. We have our 0, that's here. We have our 90, which is this one. We've done our 270, which is this one. And if we check the remaining angles, so let's find sine of 180 and sine of 360. So we're looking at our remaining angles. So if you type in your calculator there, sine of 180 or sine of 360, you should also get our theta is equal to, or sine 180 is equal to 0. So I could have theta as 180, and I could also have theta as equal to 360 degrees. Because if you go to calculator, type in sine of 360, you will get 0. So here it wants us to find all of the solutions. So my solutions are 0 degrees, 90 degrees, 180 degrees, 270 degrees, and 360 degrees. So it's basically the quadrants of the unit circle. And the final part to our trigonometric question here. Part C, given that tan A plus B is equal to that's the formula from your log tables, express tan 75 in the form A plus or minus the root of B. So from page 13, I'm going to rewrite the angle of tan 75 as an addition of two angles. 75 can also be written as 45 plus 30 degrees. And I'm trying to manipulate my tan 75 so I can rewrite it then as tan A plus B. And my A is going to be the 45 and the B is going to be my 35. So therefore, I now have tan of 45 degrees plus 30 degrees is equal to tan A, which is tan of 45. Again, this is coming now from the formula, plus tan of 30 degrees all over 1 minus tan A, so I'm just putting them in brackets here because they're being multiplied, and tan B, which is tan of 30 degrees. From page 13 in my log tables, tan 45 degrees is 1. Tan of 30 degrees is root 3 over 3. That's now all divided by 1 minus tan of 45, which again from the log tables is 1. Tan 35 is root 3 over 3. And if I go to my calculator and type in that fraction, I will get a simplified answer as 2 plus root 3. And that's what they wanted. Again, they asked to express tan 75 in the form A plus or minus root B. And I got 2 plus root 3. And that is the answer to question 5. So scrolling down now to question 6. So we're looking at question 6 now. If we take a look at the picture here, and it's asking us to show if the area of the triangle ABC is equal to the area of the triangle ADE, show that the angle is equal to pi over 6 in radians. So we're looking basically to show that alpha, that symbol A or Greek symbol, is equal to pi over 6 radians. So the key word there is area of a triangle, and they're given it in terms of the angle. So I would be drawn to our formula half AB sine C from my log tables. That's the formula for the area of a triangle. And I have the area of the triangle ABC equals to the area of triangle ADE. So I'm just going to let the formula equal itself twice. Once for the triangle ABC and the second time for ADE. And if I fill that in, if I focus in on the triangle ABC first of all, so let's just highlight it here. It's that triangle. And what do we know? We know that the A and B are the two sides of the triangle. Well, I'm given the radius here. So my A and my B are going to be R and R, standing for radius. And my angle C is going to be the angle alpha. And if we look at our shape here, you'll see that these four angles are equal in size, because it tells us in the question also that we have two parallel chords of a circle with center A and radius R. And if you remember, the definition of a chord means that the two sides are bisected when we draw that perpendicular line coming from the center of the triangle. So if I draw this line up the center, that then splits this angle into two equal parts. And similar then, that the two angles on the triangle BCA would also be split into two equal parts. So we'd have this line here equal in length to this line here, which tells us that these two angles are equal. So in other words, basically, the four angles there are equal in size. They're all standing for alpha. So we have all equal in size, those four angles there. So if I'm looking at the triangle again, ABC, let me just highlight it again. I'm looking at the four angles there together. So I won't be calling it sine alpha. I'll be calling it sine 4 alpha. So 4 times that alpha. And now I'm going to look at the other triangle on the right hand side, which is AD to E. And I'm going to fill it in again. And my A and my B again are the distances from the center to the edge of the circle, which is radius and radius. And my sine C in this case is going to be 2 alphas, twice the size of that angle. And when I multiply in that half, top by top, bottom by bottom will give me R by R is R squared by 1 is 1R squared, all over 2 times sine 4 alpha is equal to 1 by R is R squared over 2 sine 2 alpha. And I can now see that I have some common terms on both sides. So I'm going to divide across by r squared over 2. So in other words, they can cancel out. So therefore, I'm left with sine 4 alpha is equal to sine 2 alpha. Okay, so we've tidied it up quite a lot there now. Next step I'm going to do is I'm going to go to my log tables, and I'm going to my log tables now on page 14. And on page 14 of my log tables, I'm given sine 2a, so I'm focusing in on this one here. Sine 2a is equal to 2 times sine a cos a. So I'm focusing in on that formula there. And what I'm going to do is I'm going to manipulate my sine 4 theta, and I'm going to rewrite my sine 4 theta as sine 2 multiplied by 2 alpha. So remember that 2 multiplied by 2 alpha is still giving me my 4 alpha. So I've just factorized out a 2, and you can now see that I now have this 2a is going to be my 2 alpha. And if I fill that in then on the right hand side, that's going to give me equal to 2 sine, sorry, I just forgot my a there in the original formula for my log tables. A, and my angle here is going to be 2 alpha times cos a, which is cos 2 alpha. Okay, so that's how I've rewritten it. And next step I'm going to do now is I have to let that equal. So let me just rewrite that. So I have 2 sine 2 alpha times cos 2 alpha, and that is equal to, don't forget, that's equal now to the right hand side, which was my original sine 2 alpha. Okay, so let me just pause there for a second just to tell you what I've done. So in yellow is that, and then in blue, sine 4 alpha has now become 2 sine 2 alpha cos 2 alpha. Okay, so we've done quite a bit there. Next thing I'm going to do is, again, I can see that there's a sine 2 alpha on both sides, so I'm going to divide across by sine 2 alpha. So in other words, they can cancel out and just leave me with 1 on both sides. So therefore, I'm now left with 2 cos 2 alpha is equal to 1 when I divide it across. So when I cross it out, I must put in a unit of 1, because sine 2 theta divided by sine 2 theta is giving me 1. I'm now going to divide across by 2, so that gives me cos 2 alpha is equal to 1 over 2. I'm going to get 2 alpha on its own by finding cos inverse of a half, and when I find cos inverse of 1/2, I get 1 over 3 pi equal to 2 alpha. And to get alpha on its own, I'm going to divide across by 2, so 1 over 3 pi divided by 2. So just make sure your calculator here was in radians, because the question wants our angle to be in terms of radians. So therefore, when I divide that on my calculator, I get alpha is equal to pi over 6. And if you look back up to the top of the question, that's what they wanted us to find. Okay, scrolling down now to part 2 of that question. And in part 2, the question is read simply as find the value of r when the length BC squared plus DE squared is equal to 36. So what I'm going to do first of all is I'm going to draw out both of those triangles that contain the two sides BC and DE. So I'm just going to sketch them out because I might need to look at them now in greater detail. So the first one here I'm drawing out is going to be the triangle A. In the center I have B and C. So that's the first triangle. And I know that the angle in the center is 4 alpha. And I have a radius and a radius. I'm then going to draw out my other triangle, the triangle ADE. Now they're in no way to scale here, so it's just sketching for me to be able to read off them. So I have or and or, and I have a 2 theta here. Okay, so what do we know? We also have, if I focus in on the smaller triangle for a second, they also mark that point F on it. And don't forget that because it's a chord, this line DE is bisected. So this length is equal in length to this here. So what I'm going to do here is I'm just going to split that triangle down the center, coming to the point F. Now that's creating 90 degrees there, coming from my chord to the center of the circle. So what I'm going to do now is I'm going to just draw out this smaller triangle from ADE. So I'm just going to bring it over again and draw this smaller triangle now. So I have the length A to F. and it's matching up then to E. And it creates that 90 degree, and it split the angle 2 theta, which is 2 alpha, into 1 alpha, or just alpha. And I have the side of the triangle being OR. So now I can use my trigonometric ratio sine, cos, or tan to find the length of the side FE. So I'm going to use my sine ratio here. So sine angle is equal to opposite over hypotenuse. And that's giving me sine alpha is equal to opposite, which is FE, over hypotenuse, which is OR. So that means when I do simple cross multiplication, I get the length FE is equal to OR times sine alpha. And if I look at my sketching here, that's the length F to E here. And I also know that the length from D to F is going to be the same. So I can also say, therefore, D to F is also OR times sine theta. And when I put them together, that means that the distance from D to E can now be written as 2 OR sine alpha, when I add OR sine alpha plus OR sine alpha together. And I'm now going to come over and do the exact same thing for this larger triangle. So again, I'm going to draw a line from A down to my chord. It will split it into 2 equal parts, 90 degree angle. And I'm just going to label this point here. It was F on this other triangle, so I'm going to call it F dash. And I'm going to focus in on this part of the triangle once again. And I'm going to use my sine rule to find the length of F dash C. So that is going to give me sine angle equals opposite over hypotenuse, which is giving me sine 2 alpha this time, because the full angle is 4 alpha. I'm only looking at half of that original angle, which is 2 alpha, is equal to opposite, which is F dash C over radius. And again, if I do simple cross multiplication, I get F dash C is equal to OR times sine 2 alpha. And I also know, let's just come back up to my picture. So that's this length here. And I also know that the distance from B to F dash is also the same. So therefore, BF dash is also equal to OR sine 2 theta. So that means, so therefore, that the full distance from B to C is equal to OR sine 2 theta plus OR sine 2 theta, which gives me 2 of them. So 2 OR sine 2 alpha. Okay, so we now have BC and we have DE. And all I want to do now is I want to come up as per the question and find the value of OR, and it tells us that if I square those, my answer should equal to 36. So what I'm going to do is I'm just going to come over here to the right hand side now, and I'm going to take both of those values and square them. So I'm just going to put it up here now. So I have 2 OR sine 2 alpha, all to be squared, plus 2 OR sine alpha, all to be squared, and that equals 36. Now when I square them, so 2 squared is 4, OR squared is OR squared, and 2 alpha, sine 2 alpha, all to be squared, is written as sine squared 2 alpha. So that's how we square a sine, a cos, or a tan. Then I'm going plus 2 OR all to be squared gives me 4 OR squared, and sine alpha squared gives me sine squared alpha equals to 36. Okay, I'm now going to factorize out the 4 OR squared here. So I have 4 OR squared in both of them, so I'm going to factorize it out. So it's 4 OR squared multiplied by sine squared 2 alpha plus sine squared alpha equals to 36. I'm now going to sub in my alpha. Don't forget from part A, we know that alpha is equal to pi over 6. So I'm going to use that knowledge now, and I'm going to sub in pi over 6 for alpha. You could have done this a lot earlier, but I'm only doing it now. What I'm also going to do here is I'm going to divide both sides by 4 to eliminate that 4 here on the left hand side. So that means, so I have OR squared is equal to sine squared 2 alpha, and I'm now changing my alpha to pi over 6, plus sine squared alpha, changing my alpha to pi over 6, is equal to 36 over 9. So r squared, sorry, I shouldn't have an equal sign there, that's a multiplication, isn't it? Multiplied by the bracket. So I have r squared times sine squared, well, 2 by pi is 2 pi over 6, which is pi over 3, plus sine squared pi over 6 equals 4. And my next step is I'm now going to write it out. So I'd be using my calculator here, but just to explain what it means. Sine squared pi over 3 basically means sine pi over 3 by sine pi over 3. That's what the squared means. And sine squared pi over 6 is the same as sine pi over 6 times sine pi over 6. And that's all equal to 4. And if you go to your calculator and you type in sine pi over 3 by sine pi over 3, you'll get 3 over 4. Just make sure your calculator is in radians. And when you type in sine pi over 6 by sine pi over 6, you'll get a quarter equals 4. And 3/4 plus 1/4 is 1. So r squared times 1 is equal to 4. 1 multiplied by r squared is just r squared is equal to, sorry, why am I working with a 9 there? My fault. 36 divided by 9 is not, sorry, it's divided by 4. I'm just writing down the wrong number there as I go. This is divided by a 4, which is a 9, a 9, and a 9. And a 9 here also. So hopefully you can see that mistake there from me. So r squared is equal to 9. So therefore r is equal to the square root of 9, which is 3. And that's what the question wanted us to do. Find the value of r. And we got our r to be 3. Okay, so we are now moving down to the next part of that question, which is B. So let's write down what we're given first of all. So the first thing I'm given is two triangles. The triangle A, B, and C are my corners, my vertices, and they will correspond to the similar triangle on the right. And I'm going to label the corners A dash, B dash, and C dash, because we know with similar triangles, the angles are the same size. So that's the first thing we're given. So let's follow that up by stating the angles that are equal. So I know that angle A is equal to angle A dash. I know that angle B is equal to angle B complement, and angle C is equal to angle C complement. So those angles are equal because it is a similar triangle. We know that the angles in a similar triangle must be equal. So that's basically what we're given in our diagram. We can also mark that those angles are equal if you want to maybe color them in on your diagram. So angle A is equal to A dash, angle B is equal to B dash, and angle C is equal to C complement. Okay, let's write down now what we want to prove. Basically what we want to prove is what's given up here at the top of the page in the theorem in our Leaving Cert. So we're basically just going to write that down. That's what we want to prove. So that's what we would need to prove now. Just take a minute yourself maybe to look back on our diagrams to make sure and satisfy yourself that that's the case. Basically you're showing that the sides are proportional, so the side AB is proportional to A dash B dash. You're showing then that the side BC on the larger triangle corresponds to B dash C dash. I'm just missing my dash there in my B. And on my third side, AC is proportional to A dash C dash. So that's basically what we're trying to prove, that they are equal, or in other words proportionate to each other. So now we're going to go down and mark in our constructions. And as you know, our constructions are basically what we mark on our diagram. So to make, again, life a bit easier here when you're viewing the video, I'm just going to copy down my diagram from up above, just so we can follow it. So the first construction I'm going to make is I'm going to mark a point on the larger triangle on the left. And the point I'm going to mark, I'm going to call it B dash dash. So it's going to basically be the mirror image of our angle B, our vertex B, and B dash, and it's going to be marked on the triangle AB. Now where I'm going to place it is basically going to be on the line AB, so I'm going to put it here. And what's going to happen here is that where it's located is the same distance from A, so the length of that line must be the same length as A dash B dash. Okay, so to imagine a line coming across here from B dash over to my new B dash, I'm basically putting my smaller triangle into the bigger triangle. So hopefully you can visualize that. So that's my B dash, and I'm just going to write that down. So what I've drawn. Okay, so I've marked the point B dash on the line AB, and now I also want to state that its length is AB dash dash is equal to A dash B dash. So it'll make sense now when it's written down. Okay, so that's what I know is true. Again, look at the diagram. Basically what that means is that the distance from A to B dash is the same as the distance from A dash to B dash. That's basically what that means. Okay, so next thing we want to mark is the image of C dash over on our larger triangle. And once again, it's going to be located somewhere around here, and it has to be the same distance as C dash is from A. So it's going to be located here. So I'm going to label that point. Now I'm going to label it C double dash. So it'll have two dashes there, because again, all of these C's are the mirror image of each other, because I'm trying to keep that similar triangle approach each time. So I'm going to write that down. So basically what I'm doing here is I'm marking the point C dash dash on AC. And I've also stated that the distance from A to C dash dash here is the same distance as it is from A dash to C dash. Okay, so that's basically everything that I want to construct. I have one more construction that I'm going to make, and it's just basically going to be a straight line. And it's the straight line which is going to connect B dash to my C dash. So I'm just going to mark it in here. So I'm joining a line from B dash across to C dash. So in other words, basically what I've done here is I basically picked up my smaller triangle and I've placed it into the larger triangle. So it fits in up here. That's basically what I've just constructed. Again, we just need to write that down. So what I'm going to write down is that I've joined B double dash to C double dash. Okay, so that's all our constructions. Next thing we're going to do now is we are going to move on to our proof. So we are now doing our proof. And once again, as I said at the start of the video, we are going to need a lot of our Theorem 12 knowledge here. So make sure you viewed Theorem 12 before moving on here. So the first thing we know is that we have two congruent triangles. We have the triangle A dash, B dash, C dash is congruent now to A, B double dash, C double dash. Those two triangles are congruent because we fit the smaller triangle into the larger triangle through our constructions up above. So that's the first thing I'm going to note here as part of our proof, so that those two triangles are congruent. Okay, so that's the first thing that I'm stating, and I'm basically just going to use a little bit of a process that we did with our congruent triangles. I'm basically just going to be making statements here, and I need to give a reason. So I'm through my proof, these are the how I'm going to do it. So I'm going to make a statement, and I'm going to also state why that is the case. And why are those two triangles congruent? Well, I could look at the likes of I could do side angle side perhaps. That's one way we could have looked at it. Again, remember we can't use the three angles, but I could use the side A B dash dash is corresponding to A dash B dash. So have a look at that and I'm sure you can figure out why they are congruent. But that's one way we could do it, side angle side. Okay, what I want you to see now is we're going to look at some angles. So we know that this angle in here, angle A B double dash C double dash, is equal in size to this angle here, ABC. So those two angles are going to be equal in size. And the reason why they're equal in size is because they are corresponding angles. We could say now that the two sides, B to C, is parallel to the line B dash dash C dash dash. Those two lines are parallel to each other because we fit that small triangle into the larger triangle. So we know that they are parallel to each other. So basically that's all I'm going to state. I'm going to state that those two green angles are equal in size. And my reasoning for that, the reason for that is that they are corresponding angles. As you know, because the two lines are parallel to each other. Okay, and from that now, because those two angles are equal in size, we can now conclude that the length B double dash C double dash is equal to BC. that they are parallel to each other. So that's what, or sorry, not equal in length, they're parallel to each other. So that's what we can conclude from that statement. So we have our two angles are equal. Remember that the congruent triangle fits into that larger triangle. So that's why we are saying that they are, again, I meant to rub out my equals, they're not equal, they are parallel to each other. So we know that the length BC is now parallel to B double dash C double dash. Okay, now what we can state is that we know from our knowledge of Theorem 12, because the two triangles are fitting into each other, Theorem 12 now states that those sides are proportional. So from that, we can now state that, I'm just going to zoom in here for 1 second so I can make a bit of room. So we can now state that the side AB over A double dash B, so that side there, is proportionate to AC over AC double dash. So just take a second to look at that. So the side AB over A double dash B is equal or proportional to AC over AC double dash. Again, that's because of Theorem 12, and we don't need to prove that again. We've done that proof in Theorem 12. And from there then, we can extend that even further. We can now say that the side AB over A dash B dash is equal to AC over A dash C dash. We're just basically extending that knowledge of just up above. So again, I'm just going to zoom out a little bit so we can get our picture. If you look up at our picture, what I mean by that is that the side AB is corresponding to AC. So you can see here that they're the two longer sides on the triangles. And on the bottom of my fracture, or the denominators, is going to be A dash B dash and A dash C dash. Okay, because we know that that's the same as the length from A to C double dash, just from up here. We know that they are the same thing. And finally, we're going to make our final statement, which from there, we can now say that B dash over C, or sorry, BC over B dash C dash is equal to AB over A dash B dash. Okay, so that's basically what we can conclude. And you can see here now that we are basically finished, because we have our AB over A dash B dash is equal on top and bottom. So that must mean then that the AC over AC dash must equal the BC over B dash C dash. So hopefully you can see there that you can see that both of these are on the top and the bottom. So logic follows that the other two sides must be proportional as well. So basically what you're stating there, our final answer is basically what we wanted to prove, and that was AB over A dash B dash is equal to, because that's this part here basically, is equal to BC over B dash C dash, which is this part here, and that is also equal to AC over A dash C dash, which is this one here. So we're into section B now, the long questions. Question 7, the mass eggs laid by battery hens are normally distributed with a mean mass of 75 grams and a standard deviation of 1.3. A random sample of 1,200 eggs are chosen. Use the empirical rule. Calculate the number of eggs which are expected to lie between 73.7 and 76.3. So I've highlighted the important bits there, the normal distributed and the empirical rule. So our normal distribution is our bell curve. And what that's telling us then is that the mean lies in the center, which is 75 grams. And the empirical rule basically tells us that if we go up 1 standard deviation and back 1 standard deviation, the data between those two figures is 68% of all of the data. So that's what we're using here as part of our empirical rule, our 68%, our plus or minus 1 standard deviation. And let's see, is it 1 standard deviation? Well, if we take our mean, which is 75%, 75 grams, and we add on and subtract our standard deviation, our one standard deviation to begin with. Let's see what those figures give us. So if we add one standard deviation, so 75 plus 1.3, and lo and behold, as per the question, that brings us to 76.3 grams. And if we take away one standard deviation, it's 75 minus 1.3 grams is giving me 73.7. And they're the two grams that are given in the question. So in other words, that's our 68%. So it says use the empirical rule, calculate the number of eggs. So in other words, we basically want to find 68% of our 1,200 eggs. So if we divide 1,200 by 100, multiply by 68, we're getting 816 eggs. And that's A part 1 done. Down to part 2 now, question 7, part 2. It says use the empirical rule, calculate the number of eggs you would expect to lie between 73.7 grams and 77.6 grams. So once again, I'm going to draw out my normal distribution. And once again, your mean lies in the center. And we're going back now, so we're looking for between 73.7 grams. So if we take our mean and we subtract one standard deviation, we got from part 1 to be 73.7 grams. So we're going back one deviation, basically, which brought me to 73.7 grams. Now, when we went forward one standard deviation, that brought me to 76.3 grams. But this question wants 77.6 grams. So let's see what happens when I add a second standard deviation to that. So I'm adding 76.3 plus an extra standard deviation. I'm getting up to 77.6 grams. And that's what they wanted us to find in the question. So in other words, 77.6 grams represents plus 2 standard deviations. And basically what I now have to do is I have to find out what percentage of the data lies between these two figures. And the first one here on the left of the center, this part here, well, remember that one standard deviation is 68%. So what I'm going to do there is I'm going to take my 68%, I'm going to divide it by 2 and get 34% because the graph is symmetrical. So this part here represents 34% of my data. So in here is 34%. And remember that 2 standard deviations plus or minus represents 95% of the data. So I'm going to divide 95% by 2 and I'm getting 47.5%. So 47.5% represents this portion in here, half of 95. So I'm just going to write in 47.5%. And to get the total there, we add our 34 and our 47 together. So therefore, 34% plus 47.5% is giving me 81.5%. And again, it's asking us to find the total number of eggs. So basically what I'm doing here now is I'm finding 81.5% of 1,200 eggs, which is giving me 978 eggs. And that's A part 2. Scrolling down now to B. So here it's telling us that the owners of the egg farm changes the feed for the hens. A random sample of 40 eggs was chosen and showed mean mass difference to 75 grams. The sample had a mean mass of 77.2 grams and a standard deviation of 1.5. Carry out a hypothesis testing at a 5% level of significance to determine if there is evidence that the change of feed has resulted in a change in the mean mass of the eggs. So part 1, state the null and the alternative hypothesis. So this is hopefully straightforward. So my null hypothesis, first of all, which is also called N0, And if I state my null hypothesis, this is basically stating the claim in the question, which is that the mean mass of the eggs is 75 grams. So I'm just going to state here the mean mass of eggs is 75 grams. So that's what we have originally in part A. And my alternative hypothesis is denoted as N1, and it's the opposite of this. Just think about including the word not in our question, or in our alternative hypothesis. So the mean mass of eggs is not 75 grams. It's different to 75 grams. And this is basically the claim that the farmers have made, because it says here that of a random selection of 40 eggs was chosen and showed that the mean mass different to 75 grams. And that's part 1 done. Part 2, construct a 95% confidence interval for the information above. So basically what we're doing here is we're finding our confidence interval of the mean. So I'm just going to write that down, confidence interval of the mean. And the formula for our confidence interval of the mean is by taking the sample mean, and then I'm going to add on and subtract 1.96 times my standard deviation divided by the square root of the number of eggs. So let's fill in our formula now for the data. So my x, as we said, stands for our sample mean, which is 77.2, and I'm going to subtract 1.96 times my standard deviation, which is 1.5, over the square root of n. So that's the subtraction part. And what I'm basically trying to find here now is my mean is going to be between, or my mu, that symbol stands for mean, is going to be between the minus and the plus. So I'm going to do the same out now for a positive 77.2 plus 1.96 times my standard deviation divided by the square root of the number of numbers. And the number of numbers, or the number of eggs, is 40 eggs. So I'm just going to substitute my n with a 40. Okay, and then you go to your calculator, and for the subtraction, for the minus, I get 76.74 is my mean is between, and for the upper limit, I'm getting 77.665. So my mean, I'm 95% confident my mean will lie between, my average there is between 76.74 and 77.665. And what the question now wants us to do in part 3 is to interpret this result in light of the statistical information given in our question. So what I'm going to say here is that since our mean of 75 grams is lying outside of this interval, I am going to reject the null hypothesis and accept the alternative hypothesis that the mean of the eggs has actually changed. So that's what I'm going to state. So there we are. So that's part B done. And just to recap there in part 3, so as the mean of 75 grams lies outside the interval of 76.76 to 77.67, i.e. my answer from part 2, I reject the null hypothesis and accept the alternative hypothesis that the mean mass of eggs has changed, that it's not 75 grams. Okay, moving down now to part C. So we're getting into a little bit of probability with part C. So the probability of an egg being deemed bad is 9%. A random sample of 20 eggs is chosen, and the first part of this question is calculate the probability correct to 1 decimal point that fewer than 2 eggs will be bad. So basically what that means is, if we write it down, I have the probability of no eggs being bad, or the probability of just 1 egg being bad. So that's basically what that question says, that fewer than 2 eggs will be bad. So that means no eggs are bad, or 1 egg is bad. And we know that in probability the word or is addition. So we're going to be adding 2 fractions together, or 2 probabilities together. And what I'm going to use here now is I'm going to use my binomial distribution, because it's either good or bad and I have a set number of eggs. So that's why I can use my binomial. So what that is going to give me, so looking for no eggs being bad. So I have a sample of 20, and from the 20, I'm going to pick none of them to be bad. And I'm then going to multiply that by the probability of an egg being good, which is 0.91, the opposite of 9%. So just remember that the question here is giving us 9%, and to turn that into a decimal, we just divide 9 by 100 and we get 0.09. So what I've done there to get the probability of a good egg, I've gone 1 minus 0.09, which is 0.91. So that's the probability of a good egg, and I want 20 of those, so to the power of 20. And I'm going to multiply that by the probability of a bad egg, which is 0.09 to the power of 0. And I'm just going to put that into a large bracket. I then have the OR word, which basically means addition in probability. And now I'm getting into the probability of picking one egg that is bad. So of the 20 eggs, so 20 choose 1, multiplied by the probability of a good egg, which is 0.91 to the power of 19, multiplied by 0.09 to the power of 1, because I want my one bad egg. And I'm going to close my bracket. And now I'm going to do out those multiplications on my calculator. So I'm getting 0.1516 for the left, and then for the probability of one egg being bad, I got 0.299, and I get 0.4516. I want to turn that back into a percentage because the question is giving me the data in percentages. So that's coming out at 1557 on my calculator. And when the question wants it to one decimal point, so therefore the probability of picking fewer than 2 eggs being bad is 45.2%. Okay, see part 2 now. So find the probability that the third egg bad will be the last egg chosen. Give your answer as a percentage corrected 2 decimal points. So let's have a look at that again. So what's it saying? Find the probability that the third bad egg is going to be the last egg chosen. So basically what that means is that the last bad egg is, in other words, going to be the 20th egg that you pick. So of the original 19 eggs, 2 of them want to be bad, but the third bad egg will appear on the 20th egg that I pick out. So let's have a look at that. How would that look? So what I'm going to say here is, of the first 19 eggs, 2 of them are bad. So how do we write that as a probability? So I have 19 eggs. I'm choosing 2 of them to be bad. And the probability of picking a good egg is 0.91. And of the 19, I want 17 of them to be good, multiplied by my bad egg, and I want 2 of them to be bad. So that's the first 19 eggs. And then I want my third egg, so and means to multiply, my 20th egg to be a bad egg. So I'm going to multiply this by 0.09. So just to kind of recap, here is my first 19 eggs, and this is my 20th egg. So together I do have the 20 eggs. And when I type that into my calculator, I get 0.27873 multiplied by 0.09, and that's coming out as 0.02508 as a decimal. I'm multiplying that by 100 because the question asked to give it to a percentage, which comes out as 2.508%, and the question wants us to give it to 2 decimal points. So therefore my final answer is 2.51%. So question 8a wants us to match the graph here to a particular function in the table down here. So they've given us the 3 functions and 3 graphs, g of x, h of x, and our third one there is f of x. So we basically just need to match the 3 graphs to the function. Different ways you can do this. What I'm going to do here is I'm going to match up the amplitude, and the amplitude is the factor in front of the function, which is being multiplied by the sine or the cos. So in this case, you can see here that the amplitude is 1. The amplitude in the second one here, I'm being multiplied by 3. And in the third one, my amplitude is multiplying by 2. So I just basically need to decide on which one has an amplitude of 1 unit, 3 units, and 2 units. Now the amplitude is basically the distance from the midway line to the maximum or the minimum point on the curve. So what that means is, let's take one of them here. Let's start with g of x, the solid black line. And the midway line is, well, it's going from 0 to -2. So it's going through -1. So that's my midway line here. And I'm focusing in on g of x. And you can see here that to go from -1 to the top, -1 to -2 is bringing me a distance of 1 unit in each direction. And that 1 unit represents my amplitude. So that tells me that the first function there is my g of x. And I'm now going to move on to maybe the dotted line, h of x. So look at the h of x. So it starts here, and there is the minimum point. So I'm just going to draw a line down between them, the top of the dotted curve and the bottom of the dotted curve. You can see there that the midway line is my x or y is equal to 0. So what am I going up? I'm going up 2 units, and I'm also going down 2 units. So that's telling me there that the amplitude is 2. So in other words, when the amplitude is 2, which one of these functions has a factor of 2? Well, it's the third one there. So my answer there for -2 cos of x is going to be my h of x. And by default, the third one must be, what are we missing? F of x, but let's do it nonetheless. So f of x is the gray one. So if we go from the top to the bottom, so there's the top, down to the minimum point, which is here at -1. And where's the midway line? So I'm going from -1 to +5. So that will give me a midway line as y is equal to 2. So that's going up 3 units. From 2 to 3 is, or from 2 to 5 is 3. And then I'm going from 2 down to -1, which is also 3. So the amplitude there is up and down 3. So that means that the 2 minus 3x sine x must be my f of x. Now there's different ways of looking at that. You can also look at the -1 and the 2 in front of the sine functions. That just tells you that it's moving or it's transforming or scaling your function up and down the y-axis. So if you look there at, say, for instance, let's just do one of them here, the -1, you can see there that it's crossing, the g of x function is crossing the y-axis at -1. And look, so let's do the second one here. If you look at the +2 here, you can see that that's crossing, the f of x is crossing at +2. So you can look at either the number that's been added or subtracted, or I think it's easier to look at the amplitude. You can also look at the number that's in front of the x, which is the looking at the period, but different ways. Scrolling down to part B. So I'll let you have a read of the first part there yourself. I don't think it's anything too important. It's just giving us a little bit of history. So this part here, I'm just going to ignore myself. And I'm just going to focus in on some important information for the next part. It's telling us then that the tides vary greatly with a difference of 14 meters between its highest and lowest. So that's telling me it's basically going up 7 and down 7. And the highest water mark occurs at midnight, and the lowest watermark is at 6 a.m. From this information, write down the amplitude of the tides. So look, we can use our knowledge of A here if we want, but if we were to sketch a graph, first of all, I'm going to use my y-axis as my height of water and my x-axis as time. So what would that look like here? So let's just sketch maybe. So it's a trigonometric function, so it probably goes something like this. So I'm not worried about where it starts or where it finishes, but I do know that at its highest point, it's at 7 meters, and at its lowest point, it's at -7 meters. So that's telling me that my amplitude is from the midway line up or the midway line down. So that's still giving me an amplitude of 7 meters. So therefore, amplitude is equal to 7 meters. And that is part 1 of B done. The second part now wants us to write down the period of the tides. So again, what I'm going to do here is just going to sketch a XY graph, and I'm coming up 7 meters and I'm going down 7 meters. Now we don't know again where it starts, where it cuts through any of the y-axis, but let's just say it looks, I'm just going to pick a section of the graph. So I'm going to pick out here. So it looks something like this. And again, that continues and that continues. And what do we know? So we know that at its highest is at 7 meters, at its lowest minus 7 meters below the mean. And other pieces of information that we know that it is at its highest at midnight. So I'm going to call this time midnight. And it's at its lowest at 6 a.m. So I'm calling this time 6 a.m. And this cycle will repeat. So that's adding 6 hours from midnight to 6 a.m. So again, it's going to be at its highest 6 hours later, which is at midday. And then it's going to be at its lowest once again at 6 p.m. So you can see here that in order to repeat itself, or the period, it's going between the top to the top, which is midnight to midday. So that is telling me that my period is equal to 12 hours. Looking now at part 3, taking midnight as the start of the tidal movement, which one of these functions best represents it? So what I would be using there is I would be using the f of t is equal to the b times cos c of t. One way of explaining it is maybe because it's above 0 at the start, or its highest start point is at midnight, which is above the 0 point. So they're just different ways we could look at it. So I'm going to state the function f of t is equal to b times cos c of t. Okay, so scrolling down now to part IV. So it's asking us to take the x-axis as the sea level, use the information above to sketch the action of the tidal waves. So we know that our amplitude is 7, didn't we? And it starts, we said, at this, where it crosses the y-axis is at midnight. So I'm going to put a dot here at 7. That represents, we can just do a little arrow coming out of this just for explanation. This is midnight. And we know that 6 hours later, at 6 a.m., so this is my time here, just so we're clear, and it's at down 7 meters, so at 6 a.m., so 6 on my x-axis is here. So once again, we can just draw a little denote here just for looking at it at home. That is 6 a.m. And then 6 hours later, 6 a.m. to 12 midday brings me to a new height. So there's my 12 midday. And 12 hours later brings me to 6 p.m., which is 1800 hours at its lowest point once again. So that is at 6 p.m. And another 6 hours later, it's at its highest point, which 6 p.m. plus 6 hours brings me to midnight. So 2400 hours. So that's bringing me back to midnight. And now I need to graph the function between those points. So I'm just going to label on my x-axis. So halfway between 0 and 6 is 3. So I'm going to have to cross my x-axis probably there. And then between 6 and 12 is 9. So I'm going to cross it here. And then between 12 and 18 is 15, so I'm going to cross it here. And then between 18 and 24, halfway brings me to 21, so I'm going to cross it here. So then I just draw my curve, just make sure it's freehand. And it is nice and curved when it crosses through the points. Now I'm on a screen here, so it's not the best, but hopefully you can see the way it's taking shape. And again, keep it nice and curved. Don't use a ruler. Okay, so something like that. Not the best for on a screen. And that is sketching the information. So part V, use your graph to determine how many hours a day the island was accessible. So I'm just looking at my graph here and I have it highlighted in blue. So it's accessible everywhere below the x-axis. So it's accessible from 3 a.m. to 9 a.m. and then again from 1500 hours, which is 3 p.m. to 2100 hours, which is 9 p.m. So 3 p.m. to 9 a.m. is 6 hours, and 3 p.m. to 9 p.m. is another 6 hours. So in total, it's accessible for 12-hour period. What times during the day is the tide 1 meter below sea level? So that's at -1 below my 0. So that's when y is equal to -1. So that line here. And I'm just going to drop a dotted line up to the graph, which is here, 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 and here. Again, mine is very sketchy, but if I'm looking at the times there, so what's that? About 3:15 a.m. give or take, and then between just before 9 a.m. so I'm going to say at 8:50 a.m. and again there just after 1500 hours, which is 3:15 p.m. and again finally there at just before 21, which is just before 9 p.m. which is 8:50 p.m. So they would be the 4 times that the tide is below. So question 9, Mary, Paul and David are all standing at cones to form a triangle as shown. They're going to race to a point F internal in the triangle, which is equidistant from each of them. Use a suitable construction, determine the position of the point F. So I have my 3 vertices, which is Paul, Mary and David in my triangle, and I'm looking for a point which is the same distance to each of those 3 positions or the 3 corners. So what I'm going to do there is I'm going to use my circumcenter in order to find this point F. Now I'm going to link part B to this question because it's linking it here. It's saying that they each then decide to run a race in a circular path. Each person must touch the 3 cones while running on the diagram above. Draw the path they must take. So that is going to be our circumcircle. And the circumcircle is basically the circle which has F as its center. Now you can check out a separate video which will show you how to do the circumcircle and circumcenter along with all our constructions. But for now I'm just going to copy in a picture of the diagram. So this is what it should look like, and F is the circumcenter. And you can see here that the circumcircle must pass through the 3 vertices of the triangle, Paul, Mary and David. And like you know here, so it's the distance from F out to Paul and the distance from F out to Mary and the distance from F out to David are all the same distance. And if we move down to C now, it's asking us basically to calculate that equal distance. So here we are now down to part C. Calculate the straight line distance each person must run to reach the point F. So here it doesn't really matter if you're getting the distance from Paul to F or David to F or Mary to F. They're all going to be the same distance. So we only need to do it once. What I'm going to do here is I'm going to get the distance from F to P or F to Paul. And I'm just going to write down my coordinates here. So Paul has the coordinate of 0, 7. And F has the coordinate 5, 3. And I'm going to label them x1, y1. x2 and y2, and I'm then going to use my distance formula for my log tables to find that distance between P and F. So the formula for my log tables for distance is equal to D is equal to x2 minus x1 all to be squared plus y2 minus y1 all to be squared, and that is within a square root. And then I sub them into my formula. So the distance between P and F is going to equal 5 subtract 0 to be squared. And then 3 minus 7 to be squared. And again, once it's in a square root, 5 take 0 is 5. 5 squared is 25. Plus 3 take 7 is minus 4. Minus 4 squared is minus 4 by minus 4, which is positive 16. So the distance from P to F is equal to the square root of 41 meters. And that's the answer to part C. Scrolling on down now to part D. it's asking us, taking Paul as the point P and David as the point D, calculate the angle PDF. So that's getting us to find the size of the angle D, correct to 2 decimal points. So if I just scroll back up to my picture here, they basically want us to look at this triangle here, from David to Paul to F. So I'm just going to sketch that triangle. And what we know there is that the distance from Paul to F is root 41. So that means the distance from F to David must also be root 41. And I'll need to find then this length here in order to use one of my cosine or sine rules. But let's have a look at it in a bit more detail. So I'm going to sketch out that triangle PDF. Paul, David, and F. So what's that going to look like? So it's going to look something like this. So sketch is here just to help me or yourself when you're doing a sketch. That's the reason for it. And D, and I want to find this angle in here, PDF. And some pieces of information we know is that P to F is root 41 and F to D is also 41. Now I can't use my sine rule because I don't know any more angles. It's an isosceles triangle, so I can use my sine rule, but we need to find this length here, P to D, first of all. So I'm just going to go off and first of all find that distance P to D. So I'm just going to say here, first find P to D, the distance. And I'm using my distance formula again between P, which is 0.7, and the point D, which is 9 minus 2. And I'm going to label them x1, y1, x2, y2. And I'm just going to fill them into the formula. We know our formula from the previous part, so it's x2 minus x1 plus y2 minus y1, and both of them to be squared. So that's giving me 9 minus 0, so x2 minus x1 all to be squared plus y2 minus y1 all to be squared within the square root. 9 minus 0 is 9, 9 squared is 81, plus minus 2 by minus 7 is minus 9, all to be squared is a positive 81 again, and that is giving me the square root of 162, which simplifies down to 9 root 2. So I'm just going to take that answer, I'm going to scribble out my question mark here and put in 9 root 2. Okay, so I have 3 sides to my triangle, so now I can use my cosine rule to help me find the size of that missing angle PDF. So cosine rule now. Once again, from our log tables, our formula is a squared is equal to b squared plus c squared minus 2bc times cos A. Just make sure that the a's correspond. The cos A is the angle A, and that's going to be the angle I'm trying to find. So I'm just going to put an A here beside the D, and the side across from it is this side PF, so I'm going to call that small a. And then it doesn't matter which one you call small b and small c, I'm just going to label them like that. Just make sure you get the a's correct. Filling in my formula now, small a is root 41, all to be squared, is equal to b squared, which is 9 root 2, all to be squared, plus c, which is root 41, all to be squared, minus 2 times b, which is 9 root 2, times c, which is root 41, times cos A. And root 41 squared is just 41. 9 root 2 squared is 162. Root 41 squared is 41. And then 2 by 9 root 2 by root 41 is 18 root 82 times cos A. I'm then going to put the 62 and the 41 together. Don't take away the 18 root 82 because it's stuck to that cos A. This here is stuck together, so it's like 18x. I have to keep them together. So 61 and 40, or sorry, 161, that should be, sorry, 162 plus 41 is 203, is equal to my 41 minus 18 root 82 cos A. I'm then going to subtract 203 from both sides, or moving over to 203, which is 41 minus 203 is equal to minus 18 root 82 cos A. Taking 203 away from 41 is giving me minus 162, is equal to minus 18 root 82 cos A. I'm then going to divide across by minus 18 root 82. So that's giving me minus 162 divided by minus 18 root 82 is equal to cos A. To get A on its own, I'm going to use the cos inverse. So it's the cos inverse of minus 162 over minus 18 over times root 82, which simplifies to 9 root 82 over 82. And when you find the cos inverse of that, I'm just going to write it over here. I'm running out of space. So therefore, A is equal to 6.34 degrees. Okay, that is part D. Scrolling down now to part E. Mary suggests they have a race where each person runs to the point F, then they must run and touch another person's cone but return to F each time. The race finishes when they return to their own cone. For example, taking Mary as point M, her race path would be. So let's just have a look at that on a picture. So I'm just going to scroll up here to my diagram. It'll make a lot more sense. I'm just going to rub out what I have here for a second and just explain what's happening here. So what's going on here is that Mary runs to F, and then Mary can run to Paul, but then come back to F, then run to David's cone, and then from David's cone she must come back to F before finally returning back to her cone. So that's one of the paths that must be taken. So if we're looking at it here, they've given us a little hand here. They've told us Mary's path. So Mary to F, F to P, P to F, and so on. So basically we just have to work out the distance between each of them. So first of all, I'm going to get the distance from Mary to the center. Now we have all these answers. The distance from Mary to the center is root 41. And from the center, F, Mary is now going to go to Paul's cone. And the distance from the center to Paul's cone is again root 41. From Paul's cone, she's going to return to the center F, and that is once again repeating root 41. From the center, she's now going to go to, where's she going? David's cone, which again is the same distance because these are all equidistant. From David's cone, she must now return back to the center, which again is root 41. And from the center, she will then go back to her own cone, which is root 41. So she has 6 root 41s basically, hasn't she? 1, 2, 3, 4, 5, 6. Yeah, so 6 root 41. And that won't simplify. So that's our answer there. Calculate the total distance each person would run. There's a sample route from Mary, which is 6 root 41. But that would be the same from David or who's the other person we're looking at? Paul. Okay, that's part E. Looking at part F now. David suggests it would be shorter to run in the circular path. Is he correct? Justify your answer. So the circular path is basically the length of our circle. And from our log tables, the circumference or the perimeter of a circle is given by the formula 2 pi r. And if we fill in that formula 2 pi r, we get 2 multiplied by pi multiplied by radius. Now the radius is the distance from one of the people to the center F, which is root 41. So when I multiply, sorry, that's a little bit of a scribble there. 2 multiplied by pi multiplied by root 41, we get, as a decimal, 40.23. Now my answer, let's compare that to my answer from part E. So my answer from part E is 6 root 41. When I hit my SD button on my calculator, that changes to 38.42 meters. And you can see here that the circle obviously takes longer because it's 40.23 meters, and the distance from running to the center is 38.42 meters. And I'm just going to justify my answer a little bit more. So my circle, 40.23 minus the direct route to the center, is giving me 1.81 meters. So therefore, I'm just going to state that David is incorrect. the circle root is longer by 1.81 meters. And finished. That's David's method is longer. We have one more part, which is G. Paul is coming up with a scenario. Paul suggests that running directly between the cones in the triangle path will be longest route. Is he correct? Justify your answer. So what that means is if we come back to our original triangle that they've given us in the question. So we had Paul, we had Mary, we had David. And the coordinates of Paul was 0, 7. The coordinates of Mary was 10, 7. And the coordinates of David was 9, -2. So I basically just have to get the distance around that triangle. Now the distance, first of all, from Paul to Mary is straightforward. That's an easy one to get. So Paul to Mary, I don't need to use my distance formula there. The distance is 10 meters because it is a straight horizontal line on my coordinate graph. So I'm just counting 10 units from 0, 7 to 10, 7. So from 0 to 10 is 10. What other one do we know? We know the distance from Paul to David. I think we got that. We did. We got that from part D in this question. And we got that to be 9√2. So the distance from Paul to David we have from part D. So the only one I have to find now is the third length, David to Mary. So I'm just going to write here Mary to David. And the coordinates of Mary is 10, 7. And the coordinates of David is 9, -2. So you can see here this question is using a lot of the distance formula from our log table. So there's a lot of repetition going on here. And our formula is x2 minus x1 all to be squared plus y2 minus y1 all to be squared in a square root. And that is going to get me the distance. So filling in my formula now, so we're nearly finished. X2, which is 9, minus x1, which is 10, to be squared, plus y2 minus y1 all to be squared, which is giving me -1 all to be squared, plus -9 all to be squared. -1 by -1 is 1, -9 by -9 is 81, which is giving me root 82. Okay, so next thing we need to do is we need to add up those three lengths of the sides of the triangle. So therefore, my answer is going to be 10 plus 9√2 plus the root 82. And when I add those three sides together, I'm getting 31.78 meters as a decimal. And if we take a second, you can see here now, so they want us to see is Paul's path will be the longest. Well, I'm stating that Paul's path is actually the shortest. He's incorrect because David running the circle is longer from part F, as is Mary's suggestion from part E. So I'm saying here that, so my conclusion is Paul is incorrect because David runs the circle, and I'm just going to put in brackets that was it 40.23 meters, which is longer than the 31.78 here, and David runs the circle, yeah, which is longer. And I'm just going to make reference to Mary as well, as is Mary's suggestion in part E. And what was Mary's suggestion in part E? What distance was Mary going? Mary was going 6√41, which turned out to be 38.42 meters. So you can see here that finally Paul's suggestion is not the longest, it's actually the shortest at 31.78 meters. And that is question 9. So question 10, a flagpole is attached to a vertical wall at the point S as shown. The pole is then suspended by two wires which are attached to the wall at the point P and R as shown. And it's telling us that ST and QS are both 120 centimeters and PQ, QR is equal to 90 centimeters. Calculate the length of PS. So what I'm going to look at there is the triangle PQS. I'm going to make a triangle out of this. Just make sure that you're trying to picture it in 3D here. So basically what you're doing here is you're going, this is all on the wall. So P, Q, and S are all on the wall. So I'm going from P to Q down to S. I'm making that triangle out of it. So P, Q, S. We have 90 centimeters and we have 120 centimeters. Now this is a 90-degree angle because it's the vertical wall, and the line SQ is vertical from the base of that pole, and PR is divided into 90 centimeters and 90 centimeters. So Q is basically the midpoint there of the line PR. So in order to get the length of PS, I'm going to use Pythagoras' theorem here. So I'm getting the length of this hypotenuse side of my right angle triangle, and our Pythagoras theorem is c squared is equal to a squared plus b squared. And when I sub in my formula, I have my c, which is my hypotenuse, ps squared equals, and a I'm going to call a 90, and I'm going to use b as 120. So they're my two opposite sides. So that's giving me ps, all to be squared, is equal to 8,100 plus 14,400. And in order to get PS, then I'm going to get the square root of those two numbers added together, which is 22,500, and find the square root of that. So the length of PS is 150 centimeters in length. And that's part A. Coming down now to part B, it's asking us to calculate the length of the wires used to attach the flagpole to the wall. So what I'm now going to look at is I'm going to look at the triangle PST. So PST, again, this is coming down the wall. So just picture it in 3D. That's the vertical length along the wall. It's coming over to T, and then it's I'm making that flagpole ST out of it. So the two lengths that I'm looking for here basically are the lengths from P to T. That's the length of a wire, and the other wire then is going to be the same length from R to T. Again, try and picture that as if you're looking in at the flagpole from here. So that the two wires are basically going one to the left and one off to the right. So the triangle, as I said, I'm looking at here is this 90-degree triangle. Once again, I'm now looking at the triangle P to S and across to T. So that's the triangle I'm using here now. And I know that from S to T is going against the vertical wall, so that's a 90 degree. I have PS from part A, which is 150 centimeters, and I have the length S to T to be 120 centimeters. So all I need here now is the length from P to T, and I'm going to double that because I have two wires, don't forget. So once again, I'm using my Pythagoras theorem, which is c squared is equal to a squared plus b squared, which is giving me the length PT, which again is the hypotenuse, all to be squared, is equal to 150 squared plus 120 squared. And that's giving me 22,500 plus 14,400. And that is equal to PT, all to be squared. And I'm going to add the two sums, and I'm going to get the square root of that because I'm looking for PT. So that's giving me the square root of 36,900, which is giving me a length of PT as 192.1 centimeters. Now I have two cables, so I'm going to multiply by 2, and that's giving me a total length of cables because the question asks for calculate the length of the wires used, which is giving me 384.20 centimeters in length in total. And that's part B. Scrolling down now to have a look at C. And it's asking us to calculate the angle that each wire makes with the wall, and they've given us a hint there to find the angle TPR. So what I'm going to do here is I'm going to draw a triangle, and we'll come back up to the picture and we'll see it in a bit more detail. So I'm drawing out the triangle T to P, and from T over to R. And I'm making that triangle out of it. Now if we come back up to our original picture, remember that T is the tip of our flagpole here. And what I'm basically doing is I'm now using the two lengths of my cables in blue there going off to P and R. Now they're the same length because remember that we have a 90 and a 90 here. So it's that like an isosceles triangle basically is what we're making out of it. So I'm going to just sketch in that piece of information onto my picture here. So from P to T, we have found from part B as 192.1 centimeters. And like I said, it's isosceles. That other cable is also 192.1. And we also know the distance from P to R is 90 plus 90, which is 180 centimeters. Now, because we have two sides the same, we know that these two angles are equal because it's an isosceles triangle. So what are we trying to find here now? The question is asking us to find the angle TPR. TPR is this angle in here. So what I'm going to use here, I'm going to use my cosine rule, and my cosine rule from my log tables is written as a squared is equal to b squared plus c squared minus 2 times bc times my cos angle. And when I fill that in, just make sure that your A, your small a, and your angle A correspond. So they're the two that you have to make sure you get correct. So the angle I'm trying to find is P, so I'm just going to put an A here, that's the angle. And the corresponding side to that angle is 192.1. So that's my small a. And once you get them, that's fine. Your B and your C are the other two sides, basically. So I have 192.1 all to be squared is equal to my B and my C. Well, I'm just going to use 192.1, my other side as my B, and my remaining third side as my C, which is 180 squared. Minus 2 times B, 192.1, times my 180, times my cos A, and that's what I'm trying to find. And I'm trying to find the angle P, so I'm going to call it cos P. Okay, large numbers here. So when I square 192.1, I get 36,902.41, and that is equal to, when I square 192.1 and add 180 squared, I get 69302.41. Then I'm going to subtract 2 multiplied by 192.1 by 180, and that's giving me 69,156 times cos of P. I'm then going to subtract 69,302 from both sides, or basically moving it over to the left. So that's giving me 36,902.41 subtract 69,302.41 is equal to negative 69,156 times cos of P. Just make sure now you don't subtract these from each other, because you have to do what's multiplying first. And see here, this has been multiplied, so that's why we can't subtract them. Okay, so tidying up that left-hand side, this section here, when I subtract them, I'm getting minus 32,400 is equal to minus 69,156 times cos of P. I'm going to divide across by minus 69,156, so that's giving me minus 32,400 divided by minus 69,156 is equal to cos of P. Minus divided by minus will give us a plus, and when I divide the numbers I get 0.4685 is equal to cos of P. And now to get P on its own, I'm going to do the cos inverse of 0.4685. And on my calculator, just make sure you're typing the inverse button, which is giving me an angle of P, or TPR as they call it in the question, as 62.1 degree, because the question wants it to 1 decimal point. And that is part C to the question. Scrolling down now to have a look at part D. So it wants us to calculate the angle TRS, corrected 2 decimal points this time. So what I'm going to do is I'm going to sketch the triangle here, TSR. So T to S to R. Now again, this sketch is just to help me. There's my R, T and S. Now let's come back up to the picture and let's just see the angle that they want us to find there. So T or S. And let's just rub out our drawing here and start fresh. So they're getting us to find the angle of T or S. which is here. So the triangle that I'm basically looking at is starting from T into the wall S and up then to the point OR, which is also on the wall, and I'm creating that triangle out of it. Now remember that on the wall it's vertical, so this is a 90-degree angle here, and we also have our 120 centimeters here, so I'm going to mark that on my picture now in a second. We also know from I think it's part B that the length from OR to T is 192.1, so I'm also going to fill that on my picture. So we've plenty of information there that we can use. So marking in my picture here, I have my 90-degree angle. This is the angle I'm trying to find here. And I know that from S to T is the length of the flagpole, which is 120, and the distance from T to OR is 192.1. Okay, looking at this now, the information that's provided, I can use the sine rule in this part of the question. So I'm using my sine rule again for my log tables, which is A over sine A is equal to B over sine B is equal to C over sine C. Now we don't need to go with the 3 parts, you only need to take 2 parts of it. Okay, and filling in my formula here, I'm going to use A as 120, and it corresponds to the angle OR as my capital A. I'm going to use the 192.1 as my small b, which is across from the angle S, but for my formula I'm going to call that B, which is 90 degrees. So filling in my formula, A, I'm going to go with 120 over the angle I want to find, so I'm going to call that sine OR, is equal to my B, which is 192.1 over my sine of 90 degrees. Now sine of 90 degrees is going to give me 1 on my calculator, so that's 192.1 all over 1. I'm then going to cross multiply here, and that's going to give me 192.1 times sine OR is equal to 1 multiplied by 120, which is 120. Then to get sine OR on its own, I'm going to divide across by 192.1. And I'm going to find the inverse of that then to get OR on its own. So sine inverse of 120 over 192.1. And the question wants it to 2 decimal points this time. So that's getting me an angle of OR. So let's label it the way they wanted it in the question. The angle T or S is equal to sine inverse of 120 over 192.1, which is 38.66 degrees. Okay, at our final part, we're now scrolling down onto part E. And it wants us to calculate the area of the triangle TPR. Now let's again, for the final time, come back up to our original picture here and figure out what triangle they're getting us to find. So let's rub out all this information here again, and I'm going to start fresh. So the triangle they want us to find is TPR. So starting at T, over to P, up to R. So that's the triangle. Now they've given us plenty of information here. Remember that this here is 180. We know that the length from T to R is 192.1 from part B. The distance from T to P here is the same, 192.1. Don't forget it's an isosceles triangle. We found that this angle in here was 62.1 degrees. I think we found that from part C. And this one is also 62.1 degrees, also from part C. Now we don't need it, but you can find that this angle in here is going to be 55.8 degrees because all 3 angles in the triangle must add up to 180. So there's a lot of information there that you can use. We don't need it all, but let's fill it in. So scrolling down, and I'm going to sketch out that triangle basically that I highlighted up above. So starting from the end of the flagpole T into the wall at P and into the wall at R. The length from P to R is 180, 90 plus 90. We know that P to T is 192.1. and the distance from T to R is also 192.1. We know that the angle then at P is 62.1 degrees. It's isosceles triangle, so 62.1 degrees here as well. And like I said, we can fill this angle in here as it is all adding to 180 degrees. So this is 55.8 degrees. So area of a triangle, half AB sine C is the formula that I'm going to use, because we can't use half the base by the perpendicular height, as we don't know what the perpendicular height is. Now you could go off and use maybe Pythagoras theorem, split that length from P to R to 90, but it's too much work. So half AB sine C. And filling in my formula, I'm getting, again, it doesn't matter which sides you want to use as your A's and B's. I'm going to stick with 180 as my A. I'm going to use 192 as my B, and the third side then as my C. So the angle C is going to be across from the side C, which is my R, in other words. So when I'm filling in my formula, my area is equal to a half times A, which is 180, times B, which is 192.1, times my sine of C, which is sine of 62.1 degrees. And when I type that in my calculator, I get an area of 15,279 centimeters squared. Thank you for watching another tutorial video from Tulla Maths. Make sure and subscribe.